Understanding source code management for continuous delivery toolchains. Transitioning to an agile DevOps style begins with how application assets are managed in a code repository. In this presentation, you will learn about the concepts associated with managing code in a Git-based repository. Continuous delivery toolchains interface with Git-based repositories, either hosted through GitHub or on GitLab Git repos hosted on IBM Bluemix. You'll learn the process flow of how Git-based repositories manage changes to code, commands for working with repositories, patterns of remote synchronization, and how to identify and track changes made to a repository. You can integrate Git-based repositories into a toolchain in multiple ways. You can store your source code in a new or existing repository on GitHub and engage in social coding through wikis, issue tracking, and pull requests. You can also collaborate with your team and manage your source code using an IBM-hosted Git repos and issue tracking in Bluemix Public. The Git repos and issue tracking tool integration is built on GitLab Community Edition. IBM-hosted Git repos support both public and private, that is, team access only, repositories. Or you can access dedicated GitHub Enterprise repositories when working in the IBM Bluemix dedicated platform. When configuring the Git repository tool integration, users can choose to create a new repo, fork or clone a source repository, or simply point to an existing repository. Here's a diagram of the typical workflow of managing application code with Git. Developers each have GitHub Git repo accounts and have Git installed on their computers. A developer will begin by creating a new repository, adding the base application code or framework, and then adds team members as collaborators on the project. Collaborators are able to synchronize changes to the project as a result. A repository contains one or more copies of the project organized by branches. The main branch of a code repository is typically called the master branch. To work locally with the code, project collaborators use clone to fetch a repository copy from the remote Git server. Developers can check out a specific branch to work on for a new feature. By default, if a new branch is not checked out, work is performed on the master branch. After the initial repository clone, you can use the pull command to update with the latest project changes. This incorporates non-conflicting changes automatically from a remote repository into the current branch. Once a set of changes are complete, the respective code files are staged by using the git add command followed by a list of files. After the add, the index holds a snapshot of the content that is staged for the next commit. A collection of changes in the index can be marked as ready to share by using git commit. And the git push command will take all of the assets from the commit and upload them to the remote repository. When working with a Git repository for application code, you can perform tasks using a Git Terminal or in the Orion Web IDE or within Eclipse. If you work on a local workstation, you can use the Git Terminal commands to edit the contents of your Git repo. If you use the Orion Web IDE, the Git panel supports many of these commands. And if you use Eclipse, you can work leveraging the eGit plugin. Here are some of the most common Git terminal commands. You'll see several that were described in the previous slide, like git init to create a new repository in the current folder or directory, git clone to copy a remote repository at the given URL to a local folder, git pull to update the local copy from the remote, git branch to create a new branch, git checkout to set the active branch, git add to add updated files to the index, git commit to commit staged files, and git push to send files to the origin or the remote copy. There's also a few more other commands that are very commonly used. Git status shows the list of modified files and work as a double check before making a commit. Git reset allows you to cancel any staged changes to files. And git merge, which provide tools to join development histories together. This is a flow which applies when you are not a committer to a project. If you find an interesting GitHub project and want to make modifications but are not a collaborator, you can fork that existing project. If you fork a repository, it will clone the repo as a new, unlinked starting point to your GitHub account, allowing you to synchronize changes to the fork but not the original project. With your repository in place, for example as shown here, the cool repo fork, you can clone to your workstation and begin working on some changes. But what happens if the original cool repo adds a feature that you want to have available locally? Since you've already made some changes, you can't just remove your fork of the cool repo and start over. Instead, you can define a second remote on your development system. This one is set as an upstream using git remote add upstream. This allows you to pull updates from the original repository and merge them to your local workspace. Once merged locally, you can push to the cool repo fork. Here's a summary of the actions and the respective commands to use in this scenario. If you want to list the currently configured remote repositories for your local repo, use git remote -v. To add a remote link to the original repository as an upstream source, use the command git remote add upstream, and then provide the original repo URL. Next, to sync the local repo to keep it up to date with the upstream, use git fetch upstream. This will cause any commits to the master branch to be stored in the local branch called upstream/master. Then you can check out your fork's local master branch using git checkout master, and then you can merge using git merge upstream master. This will bring your fork's master branch into sync with the upstream repository without losing your local changes. This process can be done for other branches as well besides just the master branch. Syncing your fork only updates your local copy of the repository. Once you have synced and merged, to update your fork on GitHub, you must use the git push origin master command. The continuous delivery service provides issue tracking capabilities through Git repos and issue tracking, which is hosted by IBM and based on GitLab Community Edition. Continuous delivery also supports integration with other planning and issue tracking tools, such as GitHub Issues and Jira. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its own section in every repository. When using Git repository, issues are a great way to keep track of tasks, enhancements, and bugs for your project. Once you've collected a lot of issues, you may find it hard to find the ones you care about. Milestones, labels, and assignees are great features to filter and categorize issues. Both GitHub Issues and Git repos and issue tracking provide Kanban boards for issue tracking and planning. When you are looking to resolve bugs and issues in code, there are some tools available from Git to help you track down bugs. First, there's Git bisect. This command uses a binary search algorithm to find which commit in your project's history introduced a bug. You use it by first telling it a bad commit that is known to contain the bug, and a good commit that is known to be before the bug was introduced. Then, Git bisect picks a commit between those two endpoints and asks you whether the selected commit is good or bad. It continues narrowing down the range until it finds the exact commit that introduced the change causing the bug. Git blame shows what version and author last modified each line of a file. It annotates each line in a given file with information from the revision which last modified the line. This concludes our overview of source code management using Git-enabled repositories for continuous delivery toolchains. Thanks for watching.